Hello and welcome to this short video where we want to discuss the value and the use cases of snapshot operations for SAP HANA running on Azure NetApp Files. We will cover some background information on the advantages of SAP HANA snapshot backup operations compared to traditional streaming backups. And we also talk about the speed of restore and recovery operations when using snapshot backups versus file-based backups. We will then briefly touch on other use cases where accelerated backup, restore, and cloning operations provide huge value. And finally, we will discuss the different features and workflow steps which are required to orchestrate HANA snapshot backup operations. NetApp SnapCenter will be introduced as an orchestration tool for SAP HANA snapshot backups. Let me start with a high-level comparison of the different backup methods supported by SAP HANA. SAP HANA supports two different methods for database backups. The first method is a stream backup, which could be a file-based backup or a backup using the SAP HANA Backend API. With file-based backups or backups using the Backend API, the SAP HANA database server reads the data from the primary storage and writes the data to either a file system or streams the data to a backup server using the third-party backup tool. Both approaches have a significant impact on the performance of the SAP HANA database. There is additional CPU load at the SAP HANA database server. There's additional I/O load at the primary storage, and there is a load on the backup network. In addition, the backup runtime specifically for larger databases can be significant, resulting in lower operation speed during backups. Therefore, streaming backups are typically scheduled at most once per day. The restore and recovery process can also be a challenge due to the long runtime of multiple hours, specifically with larger databases. The second SAP HANA backup method is the use of storage-based snapshot backups. With ANF snapshot backups, the backup is executed in a matter of 1 to 2 minutes instead of hours. The backup is executed at the storage layer, and there is no impact on the performance of the SAP HANA database. Also, the restore process occurs in a matter of a minute, which has a significant impact on the RTO if a restore operation is required. SAP recommends to run weekly block integrity checks in addition to snapshot-based backups. These check operations can be either done by running a file-based backup once per week or by running the HANA HTTP Burst Direct tool against a snapshot backup. This screenshot shows the backup catalog of a customer running SAP HANA on Azure NetApp Files. The backup catalog includes file-based as well as snapshot-based backup operations. The catalog shows two file-based backups. One of them took around 2.5 hours, the other one around 4 hours. All the different snapshot backups got finished in around 1 minute and 20 seconds. This results in a backup runtime reduction of 99%. Now let's go into more details and discuss the optimization of backup operations by comparing the backup runtime between file-based and snapshot-based backups for different HANA database sizes from 1 terabyte up to 32 terabyte. The blue bar shows the file-based backup, the orange bar the snapshot-based backup. While the backup runtime with file-based backups increases with the size of the database, the runtime of snapshot-based backups is always in a range of a few minutes, independent of the size of the database. With file-based backups in larger databases, the backup runtime rises to multiple hours and is not an option anymore for most customer environments. For these large HANA systems, snapshot-based backup operations provide a backup runtime reduction of more than 99%. Now let's see how optimized backup operation influence the runtime of a restore and recovery process. The graph shows a comparison of the runtime for a restore and recovery operation using a HANA system with 8 terabyte RAM, which is around 4 terabyte database size on the file system. The bar on the left side shows a restore and recovery operation using a file-based backup. The other bars show the runtime with different frequencies of snapshot backup operations. A restore and recovery operations consists of 3 main steps: the restore of the database data, the recovery using log backups, and the start time of the HANA database, which includes loading the data into memory. The HANA startup time is always the same, independent of the used backup method.
For the file-based backup on the left side, the restore time is almost 5 hours. In worst case, recovery needs to be done using the logs of the last 24 hours with a single backup per day. The recovery time would be more than 2 hours.
With a single snapshot backup per day, the runtime is reduced due to the fast restore operation, which is always in a range of seconds, independent of the database size. The recovery time remains the same since we still have only a single backup per day. With a higher frequency of snapshot backup operations, the recovery runtime can be reduced since less logs need to be applied during forward recovery. With a doubled backup frequency, the recovery time is reduced to half. Keep in mind that snapshot backup operations do not have any performance impact on the HANA system and can therefore be scheduled to run multiple times per day. The graph also shows that a snapshot backup frequency of 12 or 24 backups per day does not have a big influence anymore on the overall runtime. Therefore, 4 to 6 snapshot backups per day make most sense and is the typical frequency used in our customer base. Typically, restore and recovery operations are tied to service level agreements, which define the maximum acceptable time for these operations. The bars on the slide show the 3 components of a restore recovery operations for different RAM sizes of the HANA database. The orange component is the database start, the green one the restore from a file-based backup, and the blue one the recovery operation. All 3 components are dependent on the size of the database, and therefore the total time increases with the database size. When drawing a line for an SLA of 2 hours, we see that a HANA system with 4 TB RAM is the maximum size that can be restored and recovered within the maximum time of 2 hours. For larger databases, the SLA can't be fulfilled. When increasing the SLA to 4 hours, we would reach maximum 4 TB RAM, but still larger systems can't be restored and recovered within the required time frame. Now we add the same bars for restore and recovery snapshot operations. The size of the orange component, the database start time, does not change. The restore time is reduced to a minute independent of the size of the HANA database. And the recovery time, the blue part, is also reduced since less logs need to be applied due to 6 snapshot backups taken per day. The graph shows that we can achieve an SLA of 2 hours for HANA databases up to 12 TB and up to 24 TB with an SLA of 4 hours. There are multiple use cases for backup recovery and cloning, where the acceleration of these operations provide a huge benefit. Executing backups is a critical part of any data protection strategy. Backups are scheduled on a regular basis to ensure that you can recover from system failures. This is the most obvious use case, but there are also other SAP lifecycle management tasks where accelerating backup and recovery operations is crucial. An SAP HANA system upgrade is an example where an on-demand backup before the upgrade and a possible restore operation if the upgrade fails have a significant impact on the overall planned downtime. With our example of a 4 TB database, the planned downtime can be reduced by 8 hours using the snapshot-based backups and restore operations. Another use case example is a typical test cycle, where testing needs to be done in multiple iterations with different datasets or parameters. When leveraging the fast backup and restore operations, you can easily create save points within your test cycle and reset the system to any of these save points if a test fails or needs to be repeated. This allows to finish testing earlier or enables to do more testing in the same time and improving test results. When snapshot backups have been implemented, they can also be used to address other use cases which require copies of a HANA database. With Azure NetApp Files, you can create a new volume based on the content of any available snapshot backup. The runtime of this operation is a few seconds, independent of the size of the volume. The best known use case is the SAP system refresh, where data from the production system needs to be copied to the test or QA system. By leveraging the ANF cloning feature, you can provision the volume for the test system from any snapshot of the production system in a matter of seconds. In a second step, the new volume needs to be attached to the test system and the HANA database needs to be recovered. The second use case is the creation of a repair system which is used to address a logical corruption in the production system. In this case, an older snapshot backup of the production system is used to start a repair system which is an identical clone of the production system with the data before the corruption occurred. The repair system is then used to analyze the problem and to export the required data before they got corrupted. The last use case is the ability to run a disaster recovery failover test without stopping the replication and therefore without influencing RTO and RPO of the disaster recovery setup. When ANF cross-region replication is used to replicate the data to the DR side, the production snapshot backups will be available at the DR side as well and can then be used to create a new volume for disaster recovery testing. All basic snapshot operations are available through the Azure portal and APIs. Within the Azure NetApp Files volume view, you can create snapshots of the ANF volume, but this snapshot won't be consistent from the application perspective. Available snapshots can be used for different restore operations. A restore to a new volume creates a new volume based on the content of the snapshot. It's actually a clone of the original volume. Restore files can be used to restore a selection of individual files, either to the original place or to a new directory within the original volume. And a volume revert operation will revert the volume to the content of the snapshot. From the feature point of view, all use cases we have discussed before can be covered, but the missing piece is the application integration. Creating application-consistent snapshot backups of a HANA database requires to execute a set of SQL statements in combination with the ANF snapshot backup operation. Before and after the ANF snapshot is created, database queries and unqueries commands need to be executed. When the backup operation is finished, the snapshot backup needs to be registered in the HANA backup catalog. On a weekly basis, HANA database block integrity check operations should be executed in addition to snapshot backups. The block integrity check is done with a file-based backup. And finally, binaries and configuration file backups should be part of the backup strategy, so the HANA shared volume needs to be backed up as well. Retention management and housekeeping is another requirement for backup operations. For each backup type, snapshot backup or file-based backup, or backup of the HANA shared volume, individual retention must be configurable. The orchestration tool must delete backups based on the defined retention and must also handle HANA backup catalog retention management. And finally, housekeeping of log backups is critical to ensure that space on the file system as well as entries in the HANA backup catalog are not growing exponentially. NetApp SnapCenter provides the required workflow orchestration to support HANA snapshot backup operations with Azure NetApp Files. We have created a series of demo videos to showcase how SnapCenter can be used to optimize data protection operations of your SAP HANA landscape. Currently, we have covered the configuration, the backup operation, and the restore and recovery process. More content will be provided according to new features coming with SnapCenter. So if you are interested in more detailed information, that's a good starting point. With that, thanks a lot for watching the video. Take care and bye-bye.